Hey everyone, it's Mr. Carr, and today we are going to be going over 1.2 Day 2, Midpoint and Distance Formula. Okay, before we work into that, let's review Pythagorean Theorem. Hopefully you saw this in middle school, but in case you didn't, this is what Pythagorean Theorem is about. Okay, so if you have, sorry, no, I don't want to say. Okay, if a triangle is a right triangle. Okay, so this has to be a right triangle, which I'm going to use that little square in the corner there to show that this is a right triangle. Okay, so if a triangle is a right triangle, then the sum of both legs squared is equal to the hypotenuse squared. Okay, I know that's a long definition there for that one. You've probably seen it this way before, where you've seen A, B, and C, okay? Then A squared plus B squared equals C squared, okay? This is accurate. This is what we're trying to say here. So these are what's called legs. In a right triangle, the legs are attached to that right angle. That longest side is what's called the hypotenuse. Okay, so the shortcut for a lot of people is a squared plus b squared equals c squared, but I could also state this as leg squared plus leg squared equals hypotenuse squared. All right, and what that's going to help us with is thinking about lengths of segments on a coordinate grid. So for example, down here, lengths of segments when graphed diagonally. Find the length of segment RT where R is -1, 0, and T is 4, 2. So 1, 2, 3, 4, and 2. So if I talk about the length of that, what I can do is I can recreate a right triangle. On a coordinate grid, these grid lines are all going to be right angles like that. Oops, don't know why I did that. Okay, so what I did was I just created a right triangle. On a coordinate grid, I'm just going to count out both legs. So if I look at this first leg, it's 1, 2 here, and then 1, 2, 3, 4, 5 here. So if I want to find the length of RT, then I can do 5 squared plus 2 squared equals RT squared. Okay, this kind of a formula, if you think back to what you did in Algebra 1, we are going to do 5 squared is 25, 2 squared is 4, and RT squared is still like that. So I can take 25 plus 4 is going to give me 29, and that equals RT squared. So the thing to remember is, if I want to undo that squared idea, okay, I want to get rid of that squared. What I need to do is take the opposite of squaring, which is the square root. If I take the square root of both sides, then I'm going to be able to cancel out that squared. So square rooting a square like that turns this into RT, and then I have the square root of 29, which as an exact answer would just be this. This is my exact version, okay? If it was like a perfect square, let's say it was 36, square root of 36 is 6. I would go ahead and do that as my exact answer. This right here is going to stay like that as an exact answer. Or if I plug this in a calculator, it comes out to 5.385. I'm going to use this symbol to mean approximately equal to RT there. Okay? So just, you need to pay attention to when it says exact versus approximate. Approximate is going to be a decimal number because it's rounded off. Exact is going to leave the radical sign in the answer. All right? Pythagorean theorem leads us directly into what's called the distance formula. Distance formula, if I just pick 2 points somewhere on here, I'm not going to label them because I don't want to scale it. I want to call them, call it x1, y1, and x2, y2. So if I look at that line, okay? I want to know how to find that, let's say without a graph. This is just visually so you can see that that's a straight line between those points. Remember, x1 and y1, x2 and y2, we use subscripts to show when things that we want to name things differently from each other, but we don't want to use a different variable. Like I don't want to call it A, B, and then C and D. I want it to be X, Y, X, Y, but I want to name them a little bit differently. So that's why I use X1 versus X2, Y1 versus Y2. So now when I look at this, we can show that distance formula. We can actually find this by using a formula like this. It's going to be X2 minus X1 in parentheses squared plus y2 minus y1 in parentheses squared. And that whole thing is going to be the square root. This is how I find distance without a graph. Okay, so on this case, we see that there. I'm going to tell you right now, maybe we'll do this in class, but this is related to Pythagorean Theorem. This has a direct connection. So take a look at that and maybe think about how does this relate to Pythagorean Theorem? Just think about it a little bit. Okay, well, let's look at down here. So find the distance between 2, -1 and 5, 3. So I'm going to do this with the distance formula. Then I'm going to do Pythagorean Theorem on the graph just to show that both are the same. So my distance formula, as you can, okay, yep, right there. I can pull it up right there. Okay, it's going to be the square root. And here's the thing. It does not matter which one I call x2 and x1. Just be consistent. So if I want to call these x1, y1 right here, and x2, y2 for my second set, that's fine. If I flip them, that's also fine. I see some students make mistakes where they try to make 2 and -1. They call both of those x's. And then 5 and 3, those are the 2 y's. Be careful of that. Don't do that. Okay, make sure it's x and y, x and y. All right, so I'm going to go, let's see here, 5 minus 2 squared plus 3. I'm going to take 3 minus a -1. So remember, when you subtract a negative, it turns into addition. So it turns into 3 plus 1 squared. Okay, so my distance is now going to be 5 minus 2 is 3. 3 plus 1 is 4. So that's going to be the square root of 9 plus 16, which turns into the square root of 25, which is 5. I have an exact answer of 5. I don't have to worry about any decimals here. All right, so now I'm going to go ahead and look at drawing on the graph to confirm. Let's use our Pythagorean theorem. So I've got 2, -1, so that's 1 point, and then 1, 2, 3, 4, 5, and 3. So that's what I want to find there. So remember earlier, I create a right triangle. I'll just do a little dash line. Count these out. So I have 1, 2, 3 on the bottom, 1, 2, 3, 4 going up. So Pythagorean theorem, we'll just call that D for distance for now. No, wait, no. I was using C earlier for hypotenuse, so let's just use C still. Okay, so Pythagorean theorem says C squared is equal to 3 squared plus 4 squared. So that means C squared is equal to 9 plus 16. Hopefully you're seeing some connections between this problem and the distance formula. Okay, so that means that C squared is equal to 25. Square root both sides, C equals 5. Same answer. Okay, so that's distance formula. That's when I say distance, I also mean the same thing as length. So anytime I say find the distance or find the length of this segment, I'm referring to the same thing. On a diagonal, how do we find that? If you have a graph, it's real great to do Pythagorean theorem. Just make a triangle. Do that. If you don't have a graph, distance formula is very helpful. All right? Okay, midpoint formula. This is the last thing for today. So the midpoint formula, if I think of a line like this, I want to find the exact middle. So the question is, how do we get there? So one way to do this is if we look at the midpoint, I'm going to write it this way. So x mid is equal to x1 plus x2 divided by 2. Y mid is equal to y1 plus y2 divided by 2. Or I put them together like this. I just do it as an order pair. x1 plus x2 divided by 2, y1 plus y2 divided by 2. Because that's really what's happening. When I find x1 plus x2, divide that by 2, that gives me my x coordinate. Think about what this means. If I add two numbers and then divide by 2, what is that referencing? I'm going to pause it right here and let you try to answer that real quick. What happens what's the result of adding two numbers together and then dividing that result by 2? Now that you're back, here's what it is. If I do x1 plus x2 divided by 2, that's an average. It's the average of two numbers. So when I look at this example here, and if I look at the fact that I'm going from -1 to 4 in the x direction here, then my midpoint is the average of those two numbers. So that's why I can take this as so I've got my x1, -1, plus 4 divided by 2. Okay? Same thing in the y direction. It's the average in the y direction. The middle of two numbers is the same thing as the average. So in the y direction, I'm going right here. I'm going from 2 to 0. So I can do, well, or 0 to 2, doesn't really matter. But 0 plus 2 divided by 2. And let's put that in parentheses because this is a point on the graph. All right, -1 plus 4 is 3 over 2. 0 plus 2 is 2 over 2. Okay, and then 3 over 2. If you want, you can leave it as 3 over 2, or you can make it a decimal 1.5 and 1. So according to my work, my calculation here, the exact middle of that diagonal line segment is at the coordinate point 1.5, 1, or 1.5, 1. Well, let's try that out. So I've got from 0, 0, I go 1.5, 1. See, look at that. That looks pretty good right in the middle. Okay, so that point represents the average in the x direction and the average in the y direction. That's what we were trying to show with our midpoint formula. Okay, all right. You try now problems. This one is a little bit of a challenge for number 2. I'm going to save it for tomorrow. Okay, so when we meet in class on this one, we'll go over these you try now problems again. I want you to see if you can try the challenge out for number 2. Okay. If you have any questions, feel free to contact me. Come by my office hours. Otherwise, I'm going to say, have a nice day. I'll see you later.